Hello my dear students, good morning to all of you. Today we are going to discuss types of solutions. Types of solutions. See, based on the particle size, based on the particle size. Based on the particle size, these are categorized in three ways. These are categorized in three ways. Okay, first is the true solutions. Second one, colloidal solutions. Okay, third one, suspensions. So suspensions, these are the generally solutions. These are divided or categorized based on the particle size. So let us talk about the true solutions. What are the true solutions, or what is the characteristics of true solutions? So first we'll discuss particle size of these three solutions. In a first type of true solutions, actually what happening, sir, the particle size is less than 1 nanometer. In this case, particle size less than 1 nanometer. Are you getting my point? So how the solutions are forming, sir? Solutions are forming by the two components. In that, one is the solvent, one is the solute. Assembly torrent, one is the solvent, one is the solute. Okay, in a solvent, solute particles can be dissolved or distributed. Okay, by the distributing of solute particles in the solvent is called as a solution. Am I right or not? So here the case is different. Actually, what happening? How these three types of solutions are forming? Do you know? True solution, colloidal solution, and suspensions. How they are forming? Do you know? Actually, here particle size, based on the particle size, these are forming. But actually, what happening when the particle size? Okay, for example, I am taking the solvent and solute. Two substances are there. Okay, solute particle size is more. Then what happening? You know, here the completely miscible, partially miscible, immiscible compounds or solutions are forming. Due to that, what happening, you know, these three types of the solutions are forming. Okay, now the particle size is less than 1 nanometer. But in this case, particle size is, particle size 1 nanometer to 100 nanometers. 1 nanometer to 100 nanometers, the range should be there. But here in this case, particle size is greater than 1000 nanometers in this case. Are you getting my point? This is a homogeneous mixture. What I am telling, this is a homogeneous mixture. It means this is formed by the completely miscible compounds. This is a heterogeneous mixture. What is this, sir? This is a heterogeneous mixture. Okay, heterogeneous in nature. This is also heterogeneous. Are you getting my point? So in this case, when I am going to talk about the true solution, in the case of true solutions, we may not see particles with naked eye. Okay, particles may not visible. Are you getting my point? Particles may not visible. Particles are not visible. In this case also, particles are not visible. Okay, particles are not visible. But when I am passing the light, we may see, do you know, particles of colloidal solution. So particles are not visible. In this case also, particles are not visible. We may not see with naked eye. We may not see with naked eye in this case also. But in this case, we may see. We may see our naked eye. With our naked eye, particles are visible. Particles are visible. Means we may see with our naked eye directly particles. Are you getting my point? But in this case, I will tell you one thing. While passing the light, but it can be seen. I am writing here. But it can be seen. It can be seen by passing light. By passing light. Are you getting my point? By passing light. So this is the very, very important. So these are the here. According to the particle size, the solutions are divided into three categories. One is the true solution. Second one is the colloidal solutions. Third one is the suspensions. In the case of true solutions, particle size is less than 1 nanometer. In a colloidal solutions, particle size is 1 nanometer to 100 nanometers. In a suspensions, more than 1000 nanometers are their particle size. This is a homogeneous mixture. This is a heterogeneous mixture. It is also heterogeneous nature or heterogeneous mixture. In this case, completely miscible, two components are forming, participating to form the solution. But here, partially miscible components are participating to form the solution. In this case, immiscible components are participating to form the solution. See, in this case, we may not filter the particles. Particles. For example, solvent and solute is there. Solute particles we may not filtered through the filter paper. Here also same thing, but here it is the possible. And one thing I will tell you, sedimentation takes place. What is the sedimentation, sir? You can take, for example, in this solution. It is a solution. This is a sand solution is there. Sand, small sand we added. So you can mix it thoroughly. It is looking like a solution. After some times it can sediment. Are you getting my point? Sedimentation takes place only in the case of suspension, but in this case no sedimentation takes place. Here also no sedimentation takes place. So this is the very, very important features of characteristics of true solution, colloidal solution as well as suspensions. So what are the examples of true solutions, sir? All number of examples are there. In that I will tell one example: glucose plus water. Glucose plus water. This is one of the example of true solution. And we will see another example for the colloidal solution. Lot of things are there. Here protein plus water. Protein plus water, or gold plus water, or copper plus water. Yes, am I right or not? Then what are the examples of suspensions? Calcium carbonate plus water. Calcium carbonate plus water, H2O. These are the examples of some examples of solutions. So based on the particle size, solutions are three types. Now we'll go to the next point. In this chapter, generally we may discuss colloidal solutions. What are the colloidal solutions? We'll see now. Let's come to the colloidal solution. Colloidal solutions. In these colloidal solutions, two components were present. Colloidal solutions has two components. In that one, dispersed phase. Second one is the dispersion medium. Dispersion medium. Simply we may define. Colloidal solutions are formed by two substances. These are formed by two substances. In that one is dispersed. In that one substance substance dispersed in another substance. Are you getting my point? Okay, so what happening here, these are formed by the two substance, okay, mixing of two substances. These are formed by two substance. In that, one substance is dispersed in another substance. Okay, which is dispersed? Okay, one of the particular substance, that is called as a dispersed phase. Okay, dispersion medium, in which substitution, in which substance, okay, dispersion takes place. Assimilate or not? Okay, dispersed takes place, or means colloidal particles are aggregates. Assimilate or not, are called as dispersion medium. How simply define? How we may define dispersed phase and dispersion medium, sir? So now I am going to talk about the dispersed phase. Okay, dispersed phase. It is one of the substance. Okay, so I am writing. It is a substance. Okay, what is that, sir? It is a substance. Assimilate or not? Substance or not this one? Yes, it is a substance. Simple thing here, I will tell. It is a substance distributed. Okay, where it is distributed, sir? Generally tell me where it is distributed. Okay, it is a substance. It is a substance distributed as a colloidal particles. Okay, this is called as what, sir? Actually, particles. This is called as what, sir? Dispersed phase. Okay, so next point I am going to talk about that one. That is nothing but the dispersion medium. Okay, it is nothing but, it is like a solvent. Assimilate or not? It is equal to the solvent. It is equal to the solute. Okay, in which okay, dispersed phase or dispersed particles can scatter. Okay, scattering takes place. Okay, where it is takes place are colloidal particles. Okay, so in which colloidal particles are scattered. Okay, so this is called as dispersion medium. Means what happening in a dispersion medium? Okay, dispersed phase particles are scattering, or okay, they can distributed. Okay, this is called as a dispersed phase as well as dispersion medium. So colloidal solution has the two components. So we may define simply, colloidal solution is nothing but this is the solution formed by two substance. Okay, formed by two substances. In that, one substance is dispersed in another substance, or one substance is distributed in another substance. Which is distributed, that is called as the dispersed phase. Which in which distribution takes place, okay, that is called as a dispersion medium. Okay, let's go for the next point. Okay, no need to discuss more things here. Now we'll go to the next point. Now, types of colloidal solutions. First, I am going to talk about the types of colloidal solutions. See, so this is also different methods are there. Okay, different methods. What are that methods? We'll see. So generally I am going to talk about the classification of colloids or types of colloidal solutions. See, here based on the physical state of first type. Okay, based on the physical state of dispersion phase and dispersion medium. Okay, physical state of dispersed phase and dispersion medium. Dispersed phase and dispersion medium. Okay, dispersion medium. Dispersion medium. Okay, according to these, okay, based on the physical state of dispersed phase and dispersion medium, these are 8 types. How many types beta? These are 8 types. See, what are these are actually? How many types are these are? These are 8 types. What are these are? See, first of all I am going to taking serial. Here I am going to taking the dispersed phase. Here I am going to taking the dispersion medium. Okay, are you getting my point? Dispersed phase and dispersion medium. So, for example, I will start from the solid. Okay, for example, dispersion phase is solid. Sorry, dispersion. First type of the solution I am going to do. Okay, so colloidal solution, dispersion phase and dispersion medium. Here I am going to talk about the example. Actual as category also I will tell. Example and category. So, dispersion phase, dispersion medium, example. See here, if suppose dispersion phase is solid, okay, solid, as well as dispersion medium also solid. Okay, both are solid. Okay, in a dispersed medium, what happening? Dispersion phase can be distributed. Is right or not? So, example, these in this case examples all solid soles are welcome. Solid soles. Okay, so what are the examples of solid soles? These are called as a solid soles. Example, glass, okay, comma, alloy. Okay, these are called as a solid soles. Generally, these are called as solid soles. Next, if suppose same, I am not changing dispersed phase. It is solid only, as it is dispersed phase. But dispersion medium is liquid. Okay, what is this, sir? Dispersion medium is liquid. Okay, liquid. I am changing. This is also called as a soles. Okay, these are also called as what, sir? Soles. In this case, examples are paints and fluids. Paints, comma, fluids. I am going to taking examples. Fluids. These are also called as what, sir? Soles. Otherwise, if suppose I will take another example. Dispersion phase is same. I am keeping like that only. But I am changing the dispersion medium. Now it is a solid. Okay, it is a solid. But I am changing here dispersion medium. That is nothing but the gas. Okay, dispersed phase is gas. These are called as aerosols. Okay, these are the examples of the aerosols. See here, in this case what happening? What are the examples? Okay, dust particles. Okay, see, dust particles are moving on the whatever it may be gas. Assimilate or not? So, dust will come. Example, dust. Okay, comma. Again, another examples. Tell me, smoke. Okay, smoke. These are called aerosols. Generally, these are called what, sir? Aerosols. Aerosols. Yes. Next, I am going to change the dispersion phase now. Now, dispersion phase is liquid, if suppose. Fourth type I am taking. So, it is a liquid. It is liquid. So, here I am going to taking the solid. Here I am going to taking the solid. In this case, dispersion phase is a liquid, but dispersion medium is a solid. Then, what is the example, sir? Okay, cheese, and in this case, gels will come. Gel. See, we are using the Colgate and close-up gel. Okay, these are the gels. In this case, gels are under comes gels. In this case, so jelly. Okay, cheese. Okay, cheese. These are the examples. These are called as a gels generally. Okay, gels. Okay. Now, for example, I am taking. Okay, fifth type. Liquid and liquid. Both are liquid, if suppose. Both are liquid. So, generally these are called as emulsions. Okay, in this case, liquids are called as what, sir? Emulsions. Okay, see, examples of emulsion. Milk. Okay, milk is one of the emulsion only. Butter. Okay, butter, milk, these are the examples. These are called as what, sir? Emulsions. Emulsions. Are you getting my point? Now, next type. Sixth one, I am going to talk about that one. Next, this is the liquid and gas. Liquid plus gas. In this case, what we are doing, sir? Okay, dispersed phase is liquid. Okay, dispersion medium is gas. In a gas, what we are going to doing, sir? Liquid molecules spread out or liquid particles are distributed on the gas. So these are the examples. Okay, example of the liquid, okay, gas. Okay, that is nothing but these are also aerosols. These are also called as aerosols. In this case, we may take fog, comma, clouds. Formation of clouds are there now, you know, clouds. Okay, these are called as aerosols. Again, these are also called as aerosols. Okay, this is comes under aerosols. So, if suppose these are the 6 types. Again, what are the 2 types, sir? If suppose I am going to taking, okay, dispersion phase and dispersion medium. Okay, dispersion phase, okay, dispersion medium, I am going to taking example here. Again, one of the example I will take here only. So, if suppose this is the 7th one, I am going to taking the gas. Okay, 7th one. This is the 7th type, gaseous molecules. What is this, sir? Dispersed phase only. Now, dispersion medium is solid. Okay, in gas, solid, how it is formed, sir? Yes, it is possible. Here also possible, na? In dispersion medium. But here, gas is a dispersion phase. Means, in a solid, what happening? Gas molecules are distributed. In solid, what happening? Gas molecules are distributed. Example, fumized stone. In this case, I am taking one example, fumized stone. Fumized stone is one of the example. So, what are the categories, sir? What we may call this type of colloidal solutions. These are nothing but again same. These are called as a solid sols. Okay, these are called as a solid sols. Okay, solid sols. Next type, 8th one type. In this case, I am taking the gas and liquid. Okay, here foams are, these are called as a foams. Okay, these are called as a foams. Example, froth and whipped cream is there. Example, froth, comma. Okay, so whipped cream. So these are called as generally foams. So these are 8 types of foams. Then, sir, what about, sir? Here you wrote solid, liquid, gas. Then what about it may not form gas plus gas? No. Why? What happening, sir? For example, I am taking the dispersion phase is gas and dispersion medium is gas. Then what happening, you know, here it will be gives true solution. What it will be gives, sir? True solution. Why? Because these are the homogeneous mixtures. When gases are mixing each other, then what is forming, sir? Homogeneous mixture is forming. That is true solution. So that's why it is not a colloidal solution. So the colloidal solutions are how many types, sir? 8 types were there. Colloidal solutions are 8 types. Are you getting my point? Okay. Now we'll go to the next. So next types of the colloidal solutions based on what? Okay, basis on, we'll see. Now, we'll go to the next type of category. So, these are nothing but on the basis of nature of interaction. Okay, on the next type. Okay, on the basis of interactions of or in the basis of nature of interaction, on the basis of nature of interactions between dispersed phase and dispersion medium, dP and dm. Okay, dP means dispersed phase, dm means dispersion medium. See beta, due to this basis, these are divided into 2 categories. In that, one is the lyophilic, second one is the lyophobic. First one is what, sir? Lyophilic. Second one is the lyophobic. We'll see about that things. Okay. So, see, in this case, what is this? These are 2 types. One is the lyophilic. Second one is the lyophobic. Okay, lyophilic and lyophobic. These are divided into two categories due to this basis. So what is the lyophilic, sir? Actually, see, in this case, dispersion medium is solvent. What I am telling? In this case, dispersion medium is solvent. We'll discuss characteristics later. So, when in any colloidal solution, dispersion medium is solvent and affection between the dispersed phase and dispersion medium is more, affinity towards the dispersed phase particles is more. Okay, towards where? Towards the dispersion medium. In such case, lyophilic solutions are forming. So these are called as generally, okay, liquid loving solvents. Okay, sorry, colloidal solutions. Okay, liquid loving or solvent loving colloidal solutions. Lyophilic solutions as well as lyophobic solutions. Are you getting my point? So what is the lyophilic? Generally, these are called as, okay, emulsides. Emulsides also, these are called. Okay, we'll talk about this one. So here in this case, okay, dispersed phase exhibits affinity towards dispersed medium, DM. So more affinity is there comes close together and the attraction will be more. So that's why these are called as liquid loving or solvent loving colloidal solutions. These are called as liquid loving or solvent loving colloidal solutions. Okay, these are also called as emulsides. Okay, so now I am going to come in this. Okay, here dispersion medium is solvent, but here in this case what happening, sir? These are called as a suspensides. Okay, these are called as what, sir? Simply suspensides. See, now I am going to talk about this one. In this case, no more attraction towards the dispersion, okay, medium. Okay, dispersed phase particles has no more attraction. Okay, so dispersed phase has no attractions. See, dispersed phase DM phase no attraction, has no attraction towards dispersion media. Okay, are you getting my point? So that's why these are called as a solvent hating or liquid hating sols or colloidal solutions. So these are called as solvent hating by liquid hating colloidal solutions. Are you getting my point? See, what is the example of this one, sir? Okay, solvent loving example, starch plus water. I will take one example, starch plus water. Okay, this is the example of the solvent loving colloidal solutions. Here I am going to taking the example. Which example, sir? Generally coagulation takes place more in this case. For example, copper in water. Coagulation takes place. You can take small particles. Okay, means powdered particles of, okay, what I am telling, copper in a water solution. Coagulation takes place. So that's why here I am going to giving the example. Okay, gold plus water or copper plus water or FeOH3 plus water. Okay, a lot of examples are there. Okay, so these are the examples. Now, generally, I will discuss more about the lyophilic and lyophobic, okay, sols or colloidal solutions. In this case, what happenings are generally we'll see. So generally in this case, lyophilic colloids. Okay, I will see the characteristics. I will tell about the characteristics, how to prepare the lyophilic. So generally here what I told you, sir, these are means dispersed phase particles exhibits affinity towards the DM, means dispersion phase, means medium. Okay, dispersion medium. So that's why we may prepare easily. These are okay. So we'll discuss some other characteristics, okay, of these particular lyophilic and lyophobic. So in this case, we may prepare easy. Okay, these are easy to prepare. These are easy to prepare better. And here I am telling one thing to you people. These are stable. Why it is the stable, sir? These are stable. Why? Because so attraction towards the dispersion phase and dispersion medium particles are more. Then what happening? The bonds which are forming very strong. So that's why these are the stable one. Are you getting my point? Now generally here I am telling reversible in nature. Okay, reversible. Okay, these are reversible. Why it is the reversible? I will tell. If suppose see I prepared the starch solution. Okay, I kept in the room. Okay, after 24 hours I went and saw there. Then what happened? The solvent totally or dispersion medium totally evaporated. Okay, so what is there? Only dispersion medium will be there. Then when I am adding again water. Okay, are you getting my point? Dispersion medium I am adding. Then immediately again it will be prepared. We will prepare easily. Okay, so this lyophilic sols are colloidal solutions. So this is the reversible. Are you getting my point? In this case it is the reversible. So next point I am going to talk about that one. This viscosity is I. Okay, these are more viscous. Okay, viscosity of these solutions are I. Okay, so next point I am going to talking about that one. I want to talk about. Next I am going to talk about the surface tension. Okay, surface tension. Surface tension. Tension. Okay, of surface tension of dp dispersed phase particles lower than okay dm. Okay, dispersion phase is low than dm. Okay, are you getting my point? Okay, dispersed phase particles surface tension is less than dispersion medium. So that's why these are giving the homogeneous mixture, like sorry, these are giving the lyophilic and easily preparable. Lyophobic, difficult to prepare. Okay, these are difficult to prepare. Are you getting my point? Okay, so second one is these are unstable. Unstable. Why these are the unstable, sir? For example, when coagulation takes place, easily coagulate. Easily coagulate. So they may form the group. So it may be convert like a coagulation. So unstable. Once coagulation takes place, we will add dispersion medium again and again. Also, we may not prepare again lyophobic sols or lyophobic colloidal solutions. And irreversible in nature. Once it is formed, okay, over. Irreversible. For example, what happened, sir? For example, dm means dispersion medium is evaporated. Again, while adding the dispersion medium, we may not prepare these things. So that's why these are irreversible in nature. These are irreversible in nature. Are you getting my point? Now next, surface tension. When I am going to talking about the surface tension. Okay, see viscosity and surface tension. Okay, when I am going to talk about surface tension of dp and dm is same, almost all similar. Surface tension of dispersion phase, so dispersed phase, okay, and dispersion medium, okay, almost all same or similarly same. So these are the characteristics of lyophilic and lyophobic colloidal solutions. Okay, let's go for the next point. Okay, another type of classification. Okay, this classification based on the See. Now next one. So this classification based on the types of particles of dispersed phase. Okay, on the basis of types of particles. Okay, types of particles of dispersed phase. Particles of dispersed phase. Sorry beta, dispersed phase. See here. Okay, basis of particles. Okay, types of particles of dispersed phase. These are categorized in 3 ways. How many ways, sir? 3 ways. Okay, in that first one, multimolecular colloids. Okay, in this case, first one, multimolecular colloids. Second type is macromolecular colloids. And third type is associated colloids. See, we'll discuss all those things here. In the first case, what is the multimolecular colloids, sir? Yes, am I right or not? What is the multimolecular colloids? So, these are also called as, generally, multimolecular colloids are also called as, these are also called as micromolecular solutions or micromolecular colloids. Okay. Why these are called as micromolecular colloids, sir? Micromolecular colloids. Because here very small size dispersed phase particles are participating to form the colloidal solution. Yes, are you getting my point? Otherwise we may say here large number of small sized particles. Okay, these are having the diameter less than 1 nanometer. 1 nanometer diameter of these particles. Okay, very small size. I am telling very small size. Okay, less than. Okay, diameter less than. I am writing here. Diameter less than 1 nanometer. Okay, the particles having the diameter less than 1 nanometer, but this particle size is having the 1 nanometer to 100 nanometer. Okay, size of the particles is 1 nanometer to 100 nanometer, but diameter of the particles is less than 1 nanometer. Are you getting my point? So, see, these are held by, okay, very small size, diameter less than 1 nanometer. Here I am writing atoms by molecules. Atoms are molecules. Okay, any one. Okay, so what happening here? Molecules are held by weak van der Waals forces or held by van der Waals forces. Okay, van der Waals forces. Okay, means these small sized particles, okay, come into the colloidal range. Okay, see, these particles, small particles are this type of particles. Okay, these particles comes into the colloidal range. Okay, colloidal range. So these are called as a multimolecular colloids or micromolecular. Molecular size is very small. So that's why colloidal range is formed by the small particles. Okay, these are called as a micromolecular, multimolecular. Okay, so they are coming more. So that's why more particles, more very small sized particles, more particles are participating. Okay, number of, here I am writing, so that's why number of very small sized particles. Okay, lot of molecules are forming, participating to form the colloidal solution. So that's why these are called as a multimolecular colloids or, okay, generally micromolecular colloids. Okay, then example for this one. Okay, gold sol or sulfur sol for this one. Okay, example, gold sol, okay, and sulfur sol. Sulfur Sol. Examples. In sulfur sol, SA8 molecules. Same right or not? Number of SA8 molecules are participating. But in this case, not like that. Okay. So in this case, small sized particles are not participating. Here what happening, sir? Here is, okay, large size particles are comes into the colloidal range. In this case, okay, large size particles comes into colloidal range. See, so in this case what is forming, sir? Macromolecule, means molecular size is or atom size is more. So these dispersed phase particles are having the, okay, large size. So that's why like this macromolecular colloids are forming. Are you getting my point? See, so in this case what I am telling you, so here I will tell one thing. Large size means these are having the molar mass, means I molar mass. Okay, these are having I molar mass. Okay, I molar mass. What is participating, sir? I molar mass containing particles are participating. So that's why these are generally, okay, easily coagulates. So that's why these are lyophobic in nature. Okay, these are lyophobic in nature. Simple thing. But in this case, very small. So these are lyophilic in nature. Simple thing. These are in the lyophilic nature. Are you getting my point better? Now we'll talk about the associated colloids. Okay, what is the example of this one, sir? Macromolecular colloids. Okay, one example, starch, protein. Okay, protein solution. Protein is the one of the example of this one. So what is the associated colloids, sir? Simple thing I will tell you. So here associated colloids are nothing but, see, we'll write the things. In some cases, see, associated colloids. What happening beta here? In some solutions, colloidal solutions, okay, it's a small, means less concentration or low concentrations. Okay, at a low concentration, these are behaving like a true solutions. What I am telling you, for example, if particular solution, colloidal solution, okay, behaves at low temperature, at low concentration, like if particular colloidal solution behaves like true solution at low concentration, but at high concentration, it behaves like colloidal solution. Are you getting my point? Okay, so what I am telling you here, at high concentration what happening? It comes to the colloidal range, aggregates. Okay, at high concentration it behaves like, what, sir? Colloidal solution. So what happening here, sir? Why it is forming like this? Why it is behaving at high concentration, okay, like a colloidal solution? Because aggregates means colloidal particles are aggregates. Okay, particles are aggregates and comes into colloidal range. Are you getting my point? Colloidal range. So that's why what happening, sir? These are behaving like a, okay, sometimes true solutions, sometimes colloidal solutions. Okay, these are called as a, okay, generally associated colloids. Okay, so these are called as associated colloids in this case. C are micelles. Okay, micelles. Are you getting my point? associated colloids or micelles. Are you getting my point? This is the very, very important. So actually see, if suppose I am taking any solution, okay, so in these solutions, this is the dispersed phase particles, very less is there in this solution. What happens, sir? These are like a true solution, okay, they are not coming close together, okay, behave like a true solution. But when I am taking more, okay, this is the solution, okay, concentration, I increase the concentration, then they may come close together and they can form the like a cluster. They are forming like a cluster, comes together, close together. So now this is called as a associated colloids. The colloidal solutions which are, okay, at low concentration behaves like a true solutions, at high concentration, which means behaves like a colloidal solution, is called as a associated colloids. Okay, are you getting my point? So generally here example I will take soap solution. For example, example is a soap solution. One example I am taking. Lot of things are there, but soap I will. Why I am going to taking the soap? Soap solution. Because okay, we are having the cleansing action of soap. So soap is a one type of micelle. So that's why. And here, okay, these associated colloids are forming in particular concentration. That is called as a generally critical micelle concentration, CMC. Okay, critical micelle concentration. This is a very, very important for 1 mark question. That's the CBSE. Critical micelle concentration. Okay, so at which concentration? Okay, what I am telling here, at which concentration? Okay, so micelle is forming. Otherwise, I will define like this. Okay, see, it is the minimum concentration. It is the minimum concentration. Minimum concentration to form micelle. SM. Okay, it is the minimum concentration required to form micelle. Okay, but it is forming, one thing, here in a particular temperature and in a particular concentration only these micelles are forming. Okay, in any concentration, in any temperature, it's not forming. So, and another thing is there. Okay, this is forming in a particular temperature. Okay, so the temperature which is required to, okay, forms the micelle. Okay, so here at a particular temperature only it's formed. Okay, so that is called as a Kraft temperature. Okay, Kraft temperature KT. Okay, we will denote it by the Kraft temperature. It is formed in the particular temperature. Okay, in the temperature only it is forming. Okay, that is called as a Kraft temperature. It is a temperature. It is the temperature where micelle or micelle formation takes place. Micelle formation takes place. Are you getting my point? Okay, it takes place. These are the very, very important. Kraft temperature as well as, okay, types of Kraft temperature as well as critical micelle concentration. These are the very, very important things. Okay, let's talk about the mechanism of the micelle or colloidal solution. Okay, that will be seen in the next class. Tomorrow we'll discuss all those things about that.